Welcome to Cooking with Elastic, and in this session we're going to be going over Observability 101, but more importantly, how to process data and bring it in easily with streams. Now, you might be wondering, why am I in my kitchen? Well, if we're going to be cooking, we got to decide the right process of which we're going to process our food. We're going to use that air fryer over there to cook some chicken, the skillet, the crock pot. We're going to throw gnocchi in the blender and make some ungodly creation with chicken and gnocchi. Or we're going to do it the smart way with the sous vide. I don't know. But let's check out some streams and see what we can do with data on this episode of Cooking with Elastic.
Welcome to Cooking with Elastic and working with streams. So in this first assignment, we're going to see how we can parse unstructured data with streams using AI. Then our follow-up assignments, we're going to split them out into different groups, data sets. Then we're going to see how we can use AI to detect and alert off significant events, learn about applying retention policies with ILM quickly and easily, and then intentionally break stuff to see how we can monitor our data quality and resolve any issues when we ingest data at scale. So first things first, let's take a look at the data in question. And let's say I have some OTel data coming in from my homegrown application. So naturally, this is going to be a very custom data source itself. And a lot of organizations are like this, specifically around application logging. We can expand any of these events, see where our message field and the contents of what we're looking for, and need to be able to break that down pretty quickly and give us some insights. We can do that easily by taking some actions from here and immediately get some insights. We're going to say processing this in streams. And from here, we're going to create our very first step, and we're going to create a processor. By default, it's going to look for that body.txt and apply a grok pattern for us. But let's use AI and generate that pattern. Now, whenever we use AI, it can be good, it can be bad, but we can see the pattern that's applied here for attributes, custom order type, word, word, name, word, word, and it's actually aligning quite intently with what we're looking for, all said and done. But just in case, I'm going to take this processor or this pipeline and apply that instead. We can see exactly how everything would get broken out. So grok debugging on steroids, if you will. So we can see all the fields that are applied. We're going to go ahead and create this, and then we're going to save our changes and confirm and see where those fields are coming in. Now, if we see that this is dynamic, we probably would, in a follow-up step, review this mapping to make sure everything comes in as needed. But with ESQL, we can make those things happen on the fly if we need to. So now let's go to Discover and look at our data in action that we just parsed with streams. So we're going to copy this query. And within this query, we're going to use fields that we just parsed out, the attributes, custom order types, and then we're going to calculate the sum, convert it to a long for that custom quantity, and group it by the custom order type and the cloud.region. And like so, we can immediately see where that application data is being parsed. We're able to search off of it using ESQL, convert it to the field types that we need, and voila. All the awesomeness with streams. But we just did one data set. What if we have to do this in mass and make other groups or maybe little rivers off of our stream of data that are coming in? This is where we can process it and chop it up just as finely. So stay tuned for the next series whenever we click next. Welcome back. Now we're going to route this data where it needs to go. just the right stream itself. So within our observability UI, it's changed a little bit, but what we have is this nice handy dandy streams icon. What we're going to do is we're going to immediately pick on the logs index, the log stream itself. Notice that we have wired right here. That wired means that we can use this to route it into child streams or little rivers or creeks, however you pronounce it, to where it needs to be. We're going to partition that data itself. We're going to create partition manually. I'm going to give this name instead of a child, it's our Spark. But we're going to do this as a condition. So think of this as like a conditional processor for writing that index name. We're going to conditionally base it off the resource attribute service name equals Spark. And my cat has decided to join us. That's how intently she wants to pay attention to streams as well too. So now that that's all set and done, we've created that, saved it. Let's now suggest some partitions with AI. It'll take a minute for it to generate. You can see that there's two that are within there. Now, if these images don't align, that's okay. What's important is that we have the Hadoop instance within there. So while we created this one subset of logs.spark on our own, we could now, since we applied that condition, look for other suggestions that it would take. And since it's created this logs.hadoop with resource name equals Hadoop, or the Kubernetes deployment name equals Hadoop, or the container name, it really, really wants to define Hadoop. So let's go ahead and accept that, and then create the stream. So now we have these two where conditions and having it automatically broken out. So let's click on that logs.spark. And from here, we're going to go to our processing tab. And now on our very first step, we're going to create a processor, and we're only looking at that logs.spark stream in and of itself. Grok body.text. We're going to generate that pattern. And since we want to make sure that it aligns timestamp ISO 8601, attributes custom timestamp, /s, space, /log level severity text, space, greedy data, body text. It looks good. Actually, did a great job. And now we're going to add all those elements together. We'll create it. We can see how it's already being sliced and diced for us. Once that is created, we'll save our changes. Make sure to confirm. Then once that's done, let's go to Discover and start looking at our data in question. This time, we're going to see about those fields that we just parsed out. So we'll copy that query, apply that, run it, and voila. There's the timestamp, severity text, and the message itself. So we were able to quickly parse out, route the data correctly, and now we've done it for Spark, and we could even do it for Hadoop if we wanted to as well. That's how easy it is to start routing data. So if you had fun and you're ready to learn some more, go ahead and click next on the bottom. I'll see you in the next assignment. Welcome back. Now that we've been parsing and routing on data, let's see if we can use AI to find anything that would be significant or something we might want to alert off of. So once you get the data in, you get it nice and clean and mapped, that's only half the battle. The other half of the battle is what do you do with it? How do you make sense of it? How do you search it? And this is where with streams, we can see into that data and let AI help us ask those tough questions by just looking at the data as a whole. So go ahead and click logs.spark. Now we're going to do significant events. It says system detection, but we're going to say identify features. And once that's loaded, we're going to select that Spark instance. So this says Spark cluster, that says Spark logs, that's fine. Hopefully, I love YouTube, but not right now, early. Add to stream. Now that that's in, we're going to identify the significant events. So we'll select that Spark cluster. It says Spark logs, that's fine. Generate suggestions. And now it'll take a few moments for all the suggestions to appear. And this might not be identical for what you see within here, but you can see that we're using AI to look at the message field or the body.txt, and then try and make some queries for us that we would want to look into. So they may not be identical to what you see in the screenshot or on my screen, but what we're seeing are queries that are being created by AI by simply looking at the logs itself. So we've simply onboarded our logs, we've split them across. Now we're using AI to search our data to find areas in question. That's how easy of whenever those occurrences may be. So we can easily see some of those elements that are going on. But we'll just pick on one of these from right here. And now we have the query that's built in, came directly out, exactly from what we were looking for that specific error. What if we wanted to turn that into an alert? Simply click on the alerts on the top, create search threshold rule. It already includes our query, so go ahead and click next. We're not going to do any actions, so click next again, and we're going to give it a name. So instead of Elasticsearch query rule, say significant event, create rule, save the rule. Now, once that's done and turned, we can come over here to our alerts. And drum roll, please. Hurrah! We have our significant event. So what do? We've onboarded data with AI. We've split it. Now we've searched it and we've turned it into an alert. Pretty snazzy. I wonder what else has in store for us as we start searching through all this data. So if you're ready, go ahead and click next, and I will see you in the next assignment. Now, we're not going to keep logs forever and ever and ever, forever. We only need to keep them for a certain amount of time that only makes sense. And here, I'm going to show you how you can do that with streams. So we'll pick on that logs.spark that we just created. We're going to edit our data retention right here like so. We're not going to use the parent streams retention or where that logs index pattern that was coming from our log stream. To set it to a custom period. We want to set it for 30 days instead of the 90 days. Once that's done, click save. And then from forever, now it's 30 days. Pretty snazzy. But what if we wanted to update the ILM policy along with it? Okay, edit data retention, ILM policy, and we'll say 30 days default. Click save. Once that's done, now we can see exactly how that data is going to be, how the data is going to be aging between our hot and warm tiers. That's it. That's how easy it is. Pretty awesome. No more having to remember all the intricacies. Just as you're onboarding data, set it en masse that easy. So if you're ready to see how we would fix data that we might break, get ready for the next section. To those of you who may not know me personally, my personal motto is the meaning of life is written in regex. And I love parsing data. It is one of the most favorite things I like to do aside from cooking. So, but I know, and you might be want to sit down for this. I too make mistakes sometimes, and sometimes it's a little challenging to fix and find those errors. With streams, we make it oh so easy. Let me show you how. So again, we're going to create some failed documents, but this time for our logs.spark stream. We go to the processing tab, and that grok pattern that we applied there from earlier, Let's go ahead and edit that. So click on the three dots, not three seashells, three dots. And we're going to change our grok pattern to this. Notice this gobbledygook inside the center. We are not going to be parsing any data, any good data anytime soon. That's for sure. But we don't want to ignore failures for this processor. We intentionally want to feel the pain. So once that's said and done, update, save changes. Once those changes have been applied, we're then going to investigate the quality of our data. So go to data quality, click on failed documents, and oh, what do we have here? We have documents failing out the wazoo. And we can see exactly, because of that grok pattern that we updated, where everything is going awry. It's not going the way we want it to. Let's fix this. So while that's going in, click on processing, three dots, edit item, put it back the way it was, update, save. So now that we've updated those changes, let's go back to our data quality tab, check on failed documents. It might take a few moments. So let's shorten this time window from 15 minutes to 5 minutes. Huzzah. As we can see, more data is coming in, but there are no more errors. Eventually, this little bump in the night will go away. But what about additional issues? So let's create some more bad stuff, some degraded documents. So again, let's go to processing. But this time, we're going to create another processor down beneath. So create processor. And here we're going to explicitly look for the set processor. So these are the processors that we can do with streams out the gate. There'll be more coming as this matures. But resource.attributes.host.name, we're going to intentionally set this super duper long value. We can see, hey, it already let us know malform fields detected, and some field, not the same verbiage within there, but regardless, this is what we want. We want to inflict pain upon our index. So go ahead and click create. Once that's been created, let's save those changes. And then we're going to go back to our data quality tab to see what was going on. Data quality, we can see our degraded documents. They're coming in. These were our failed documents, or these ones that didn't even ingest. These ones are degraded. So still coming in, but not the way that we need it. Things that we could still action that we could take within our data remediation, shall we say. So with that resource attributes name, we can see it's due to field limit settings. Quality issue may not be relevant. We'll ever stream to verify. But what we know is that this data is not going to be ideal for searching for whatever our use case may be. So let's go ahead and fix what we just broke. Let's go back to processing, and we're just going to simply delete that set processor. God. Save changes. Once that's set and done churning, go back to data quality. Let's take a few moments. There's our degraded docs. We can already see starting to die back down. Between our failed documents, whenever we were going through with those, and our degraded documents, that's it. This is how easy it is to take advantage of streams for not just onboarding data, totally unique, using AI to help you parse it, then using streams to route the data to the correct index, apply the correct index policy or the retention of that data, and then should something go wrong with it, quickly fix and identify what those issues are. I hope you had as much fun as I did, and happy searching.